Part 3 of the Ocean Universe Theory. In this part of the Ocean Universe Theory presentation, we will explore the relationship of gravity and mass in both the macro and micro environments. We will answer the question of the possible unification of the atomic and gravitational fields into a single model. A mechanical or causal effect explanation for gravity has been the elusive holy grail of physics since Newton's apple fell from the tree. While we are able to identify its effects and measure its strengths, until now we have not been able to describe how gravity works in a causal effect model. We have been able to describe mass and weight in the context of their apparent effects that they display, but until now we have not been able to define the mechanics at the atomic and or the cosmic level of how mass occurs. As Mr. Wallace Thornhill explains, we have not yet had an explanation for why matter should curve space-time to create gravity in a causal effect relationship. Let's hear from Mr. Thornhill directly.
It may sound like I'm dismissing Einstein and his theories of relativity out of hand, but we have to give Einstein credit for his integrity in pointing out that his theory did not meet his requirements, and that is that his theory had to be tied back to some form of reality. And there is no explanation as to why matter should curve space to give the effect of gravity. He felt that quantum theory, being a probabilistic theory, divorced cause and effect. And this is one of the things you cannot do in physics, is divorce cause and effect. Otherwise, you might as well give up and get a real job.
The ocean universe theory meets this test because it offers a causal effect understanding of the mechanics of gravity, which can be demonstrated allegorically with models anchored firmly in our physical reality. One of the most poignant physical models for understanding gravity and mass is that of water and ice. At 0 degrees, both water and ice can coexist side by side. Ice, the solid form of water, displaces water, and in doing so, the displaced water exerts a force on the ice. In our ice-water model on Earth, this force is referred to as buoyancy, and is what allows ice to float as the displaced water becomes equal in weight to the submerged ice. We can model the effects of both gravity and mass by using water to represent energy and ice to represent matter as the basis of our analogy. Before moving on, let's look at some high-speed photography of related phenomena for our model. In these pictures you will see water solidifying around small cavitation bubbles collapsing. Cavitation bubbles will be explored in much more detail in a later section, but these photos provide us with a model to explain the formation of matter from the ambient energy in the universe, and thus the creation of mass. Archimedes first understood the concept of displacement, a fundamental of physics that dictates that two objects or particles cannot occupy the same space at the same time. This principle was formalized at the atomic level by Wolfgang Pauli and is now referred to as the Pauli exclusion principle. Mass is therefore the measure of displacement. The more energy that a particle displaces, the more mass it has. While individual atomic particles have more or less consistent masses, we will see that at the atomic, molecular, and larger level, matter has both an actual mass when at rest or slow speeds, and an apparent mass when it is moving at substantial velocities, as it will displace more energy. While Archimedes was able to use displacement to prove that goldsmiths had stolen some of the king's gold, we can use this fundamental of physics to describe and verify that gravity is not an attractive, but rather a pushing or compressive force. Because matter, the rigid state of energy, displaces energy, which is the fluid-like state of energy, matter pushes against the energy particles and they in return push back. Every piece of matter, in some sense, increases the ambient pressure of energy in the universe to some extent. Just as the process of forming ice cubes in a glass of water will increase the pressure of the water at the bottom of the glass. Because the ambient energy pressure pushing against a piece of matter is coming from all directions in the universe equally, if we have two pieces of matter anywhere in the universe, the weakest forces being exerted on them by the energy particles is along a line representing the shortest point between these two particles. Because this line of force is not at equilibrium with all the other lines of forces pushing against the objects, they are literally pushed together by the weight of the universe. While Newton thought of gravity as an attractive force, his understanding of its strength being relative to the square of the distance between two objects holds true in the ocean universe theory, where gravity is the big push. The science of hydrostatics provides us with another model to explain the interactions of gravity, matter, and mass. In using this model, we will also use terms associated with hydrostatics as analogies of what is taking place in the interactions of matter and energy. These are only analogies and are not meant to imply that energy looks like water or another liquid made up of matter particles. If we assume that energy, being the fluid state of matter, exists throughout the universe in very small units and particles, then it, like other fluids, would tend to have some level of surface tension. While surface tension may not play a significant role over large volumes, as the volumes of inscribed space decreases, the relative force of the surface tension increases. We can look to the Young-Laplace equation to help us understand the concepts of surface tension. In the animation, you will see two atomic particles surrounded by regions of increased pressure that graduates down to ambient energy pressure as you move away from the atomic particles. As the two particles come close enough together, the pressure zones start to merge in a single pressure zone that is maintained by the surface tension of the energy particles' photons develops. In the animation, you could see the two particles being pushed together by the displacement forces of the energy particles surrounding them. As the two particles came together, the energy, through a surface tension effect, joined into a single region of increased energy density. Once the regions of increased pressure of energy meet, the particles are doomed to be bound together. An interesting phenomenon occurs that may help explain why the apparent mass of a proton and its apparent size seems greater than that of an electron. As the surface tension pulls the membrane-like surface of the energy boundary taut, it leaves small spaces or voids adjacent to the particles. These empty spaces are displacing energy, and therefore increase the apparent mass of the pair so that it is greater than the sum of their individual masses. At the very minute distances making up atomic real estate, the gravitational forces are strong enough to hold particles together, regardless of any associated charges or spin. Imagine the force holding several energy particles together in its solidified form, matter, and what would happen if this force was released, if the matter were to be reliquefied, if you will, back into energy. The question we have to ask about this concept of merging fields is then, are there any other connections to this concept of merging gravitational fields to other phenomena associated with field theory? Well, beyond the analogous relationship to surface tension of water, we find an identical phenomena in magnetic currents. Let's look at a short video on merging magnetic fields before we move on.
Represent electrons flowing away from us as X's. And here at the bottom, electrons flowing towards us as dots. Applying the left-hand rule for conductors to each turn of the coil, we can begin to build a picture of the magnetic field around the coil as a whole. Since the distance between the turns of the coil is very small, we might think that the fields would overlap like this. But this is not the case. Magnetic fields do not overlap. Instead, the field of one interacts with the field of the other to produce a combined field like this. If we examine the area between two of the terms, we can see that the two interacting fields effectively cancel each other. This field interaction occurs between each of the turns of the coil, resulting in an overall field which surrounds the turns and resembles a somewhat flattened oval.
One of the phenomena associated with hydrostatics is that of a bow wave that occurs in front of an object moving through water, or a stationary object immersed in moving water, as shown in the pictures on this slide. The wave is caused by the force of displacement of the liquid by the solid object. A similar effect occurs in front of rapidly moving aircraft, ultimately resulting in a sonic boom if the aircraft can go fast enough to break the sound barrier. When a single particle or collective of particles moves through energy or ether, a similar pressure wave builds up around each of the individual atoms, and collectively around an object comprised of the atoms. As this pressure wave builds, it will move back along the object encasing it. As mass is the measure of the displacement of energy by matter, the atom or group of atoms will exhibit an apparent mass that is greater than their actual at-rest mass. Because matter is more porous than a window screen, energy is normally free to move between the individual atoms that make up an object. So the mass of an object at rest is the sum of the displacement of energy by each of the individual atoms. As an object moves faster, though, energy or ether within the matrix begins to be displaced. As this energy is expelled outward from the object, the total displacement of energy by the object increases, and therefore the object's apparent mass increases. Understanding this phenomena can be used to demonstrate why the speed of light is not actually a limiting speed, no more than the speed of sound is. We have discussed the displacement of energy, or ether particles and photons as they are sometimes called, and have learned that this displacement of energy by matter is the cause of gravity, which is an external pushing action rather than an internal pulling action between two bodies. But can gravity account for the atomic forces as well? In the pictures we see a two-dimensional representation of an atom. As we saw actual atoms in the IBM video earlier, we know for a fact that they are spherical particles of matter. If positives and negatives attract each other, like opposite poles of a magnet, then electrons should come into contact with the protons and not move around them, as we see. So why does this not happen then? The same units or particles of energy that make up the ether or fabric of space are also responsible for giving the atom its spherical shell-like structure. The spherical orbits of the electrons are maintained by the pressure of the energy particles they compress within them. The inner energy levels are higher, and it takes more force than the electron has exerted on it to penetrate this denser concentration of energy. On the outside of the orbital shell, the energy is denser than the ambient energy, yet because of the larger area, it requires a more robust electron or set of electrons to maintain the shell structure. Each shell represents an equilibrium state between the displacement force of the denser energy inside the shell, holding the electron out, and the universal forces of displacement trying to force the electron into the nucleus. These two displacement forces are in fact gravity. If atoms are held together by gravity, how do they form, and why don't the electrons collapse in on the nucleus? In the graphic on this slide, we see a progression of pictures of an atom forming. First we have a representation of matter particles that will become the nucleus, They form together, as we saw in the previous animation, of two slower particles moving together and being held together by the pressure of energy around them. Then another particle approaches at a high rate of speed, with a bow or pressure wave being formed in front of it by its fast movement through the energy or ether. This bow wave prevents the electron from ever reaching the proton and diverts it around the nucleus into a circular orbit. The displacement forces are still trying to push the electron into the nucleus, and the pressure wave keeps it from reaching it as it orbits. As the orbit gets smaller, the electron begins to move faster, until it is moving fast enough to create a hollow spherical shell around the nucleus. The outward force of the energy density on the inside of the shell becomes balanced with the inward force of energy on the outside of the shell, and the electron becomes trapped in a stable three-dimensional orbit around the nucleus. At this point, energy particles cannot pass either way through the electron orbital shell unless there is a significant change in internal or external forces being exerted on the atom. Additional shells will add to the atom until the gravitational forces are balanced, and the new free electrons coming in contact with the atom will be deflected away from the atom. We have discussed the existence of a region of increased energy pressure or density in the immediate area surrounding particles of matter. This is very similar to what is called the microclimate just above the surface of your skin or along the wall of a building. This pressure zone decreases as you move away from the object's surface at a rate inversely proportional to the square of its distance. But can we verify the existence of this region of denser energy around an atom? Let's look at another IBM video on how atoms actually affect the universe around them.
When you're watching this movie, you might notice that there are little ripples on the surface. And those ripples are actually real. What you see there are electrons that are stuck in the surface layer of this copper. The electrons in a metal, copper is a metal, electrons in the metal are always confined to the inside of the metal. This particular surface that we're using, some electrons are actually stuck in the surface. They can't come out, but they also can't go back into the bulk of the material. And that surface layer, we call it a two-dimensional electron gas, so the electrons confined in 2 dimensions. Those then behave like waves, like the waves that you see when you throw a pebble in a lake. So you see these ripples on the surface, and those are really ripples in the electron density. The number of electrons changes around the atoms.
In this video, we saw one of the validations for the ocean universe theory. First, though, I want to remind you that what you are seeing in this video is an image of an actual atom and atoms. It is not a computer-generated image or CGI. It is an actual photograph of real atoms. This is what they really look like. They're little spherical spheroids that exist, just as predicted. The atoms in the video are placed on top of a piece of copper sheeting, which is the smooth background. Note that the copper sheeting appears smooth, and this is because the surface tension of the energy surrounding it pulls the energy boundary layer taut to give it that smooth look. The ripples the narrator speaks of are plainly visible. See how they form rings around the object, like contour lines on a map. Notice how the ripples decrease in intensity as you get further away from the set of atoms. This represents one of the visual validations of the ocean universe theory. To be useful, a theory must explain things that were previously unexplainable. It has to give some new knowledge or insight into the reality around us. Spectrum absorption and emission lines have long presented a challenge for theorists to explain. One question is, how does light change from a wave phenomena to a particle phenomena when it is convenient to fit a theoretical explanation of an observation? In quantum theory, absorption and emission lines are thought to originate when a photon is somehow absorbed by an electron and is moved to a higher energy state, or when an electron somehow releases a photon and it is moved to a lower energy state. Besides the still totally unanswered question of how a wave turns into a photon or a light particle, there is a more compelling question to demand an answer to. What happens when you elevate all of the available electrons? Emission and absorption lines will last indefinitely, as long as the excitation mechanism remains active. If you have a block of a material of a finite size, it contains a finite number of atoms. A small enough block of material will contain a small enough number of atoms to be able to either raise or lower every last one of the specific electrons that correspond to the element spectrum lines. So at that point the lines should go away, but they don't. As long as you shine a light through the substance, the dark lines remain, and as long as you heat the object, the bright lines remain. Could there be another answer? Absorption and emission lines resulting from spectrum separation of light are more practically explained, and the mechanical process that creates these lines can be repeatedly demonstrated in the ocean universe theory. As we previously discussed, light is a wave propagation, and all wave propagation must occur in some medium. As we saw, this medium is in fact energy or ether, and because each unit or particle of energy is so much smaller than particles of matter, these energy particles can fill the space between atoms, as well as the space between electrons and protons. Absorption lines are simply the result of wave interference. When the light passes between atoms or attempts to go through the atomic nucleus, it results in some very specific frequencies of the light being blocked or cancelled. If you send a strong enough set of light waves through a nucleus, such as a laser, it will cause the atoms to fly apart. And the graphic displayed, you can see the various course a wave might take going through an atom. While low power waves may penetrate the outer energy shells of an atom, it would take extremely high power waves to penetrate the inner high density energy shells of an atom. Let's look at a short video that explains the different types of interference patterns that one might experience.
Interference of waves. When superposition of waves occur, they can be destructive or constructive. This physical effort, observed as a result of the superposition of waves, is called interference. In constructive displacement, a maximum displacement curve is produced. Thus, when constructive displacement occurs, the phase difference between the waves would be 0, or a multiple of 2. When minimum displacement occurs, waves superimpose destructively. The phase difference of the waves would be an odd integer multiple.
What I have here is an empty box. And this is a little eyepiece where we can look in, and this is a hole. And I'm going to place this slide above that hole. And if you look closely, you'll see that there's two openings. Very narrow openings side by side. It's a double slit. Now before we have a look, we need to tilt it towards the sun a little bit. So we want the sun to hit this double slit directly. What are we going to see on the bottom of the
obvious thing you think you're going to see is you're going to see two lines. No, not tons, but I can see dots spreading across that way.
Either side.
Yeah, definitely.
Isn't that amazing?
Yeah, that's incredible. And that's just nothing else apart from
Two slits.
two slits.
When the light from one slit met up, peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light canceling itself out.
In the video you saw how waves, including light waves, will interact with each other, creating dark lines, destructive interference, and bright lines, constructive interference. This is a well-documented property of waves in any medium, and it cannot be replicated by individual particles acting alone like bullets. Now let's look at another proof of the ocean universe's theory's position that light is a wave propagation. If light is a bullet like photon, it would go through a mass of matter, or it would be stopped by the matter. If a flash of light energizes a number of electrons, as suggested in quantum mechanics, then they should be de-energized or flash out just as fast as they energized.
And what about some still life photography? You can watch the ripples again washing over the table, the tomato, and the wall in the back. It's like throwing a stone in a pond of water. By the way, this is how nature paints a photo, one femto frame at a time. But of course, our eye sees an integral composite. But if you look at this tomato one more time, you will notice as the light washes over the tomato, it continues to glow. It doesn't become dark. Why is that? Because the tomato is actually ripe, and the light is bouncing around inside the tomato, and it comes out after several trillionths of a second. So in the future, when this femto camera is in your camera phone, you might be able to go to a supermarket and check if the fruit is ripe without actually touching it.
Let's look at some of the snapshots of this event. In the first snapshot, we see the light waves on the wall behind the tomato. Notice their shape and positioning. They resemble the water waves we saw in an earlier video, and the waves around the atoms we saw in the earlier IBM videos. Particle streams do not make this type of curved image. In the second picture, you can see the wave of light just hitting the tomato. If you look carefully at the base, you can see the curved wavefront extending out from both sides of the tomato. Now in the third photo, you can see the tomato continues to glow after the light has gone by it. This is because of the wave action in the energy matrix within the atom of the tomato continues on after the light passes. Particles would not have penetrated to the center of the tomato and caused this afterglow. Only a wave passing through the material, like an ocean wave around pilings of a pier, would be able to cause this type of effect. If there is an ether surrounding us and passing through us, then we should see other wave phenomena at the atomic level, which cannot be supported by a corpuscular theory. In fact, we do have tangible proof of another theorized phenomena at the atomic level. Atoms can be used to transmit and receive electromagnetic waves in the visible and invisible regions of the spectrum. If an atom displays emission lines, then it must be radiating at some frequency. This radiation is light, and it is called electromagnetic radiation. Because light is electromagnetic radiation, and all atoms have distinctive spectral emission line patterns, then all atoms are antennas. With the exception of some very specialized directional antennas, all antennas radiate in a 3-dimension. Now, most are designed to radiate certain frequencies better than others, and to radiate in desired patterns or directions based on their intended use. Yet, except for the antenna designers amongst us, we generally do not think of radiation as being 3-dimensional, and we certainly do not think of atoms as antennas. Our normal idea of an electromagnetic radiation graphic is like the one that is pictured in this 3-dimensional graphical animation, which is used to teach basic physics. The problem with this model is that it is not what radiation actually does in the real world. It is just a model for talking to the mathematics of vector addition and subtraction, not the mechanical reality of radiation. In this animation, we see a series of 3-dimensional models of real-world antenna radiation patterns. This is actually how radio waves and all electromagnetic waves move outward from an antenna in the real world. While not all radiation patterns are symmetrical, they are all sending a consistent waveform or field in all directions, rather than a magnetic field in one direction and an electric field in another. If a receiver could only receive one field or the other, as the two-dimensional drawing board model implies, radio would simply not work. While the vector model used in physics is helpful in explaining the mathematics, it simply cannot describe electromagnetic radiation in a mechanical process that is tied to the real world. Using the vector model to explain the mechanics of radiating wave propagation is paramount to using the Ptolemy geocentric model of the solar system to explain the mechanics of how the stars and planets actually move or to navigate a spaceship by. Yet both the Ptolemy model of the solar system and the vector model of wave propagation serve a purpose, and that is to calculate accurately the apparent observational position at any given point in time, independent of the path actually taken to get there. We often rely on physical or graphical models to discuss mathematical concepts in abstract, or as a framework to log observational and positional information in. But we have to be careful to not impress on theoretical models the validity of real-world mechanical processes. To understand how an atom acting as an antenna might operate, we can look to the radiation characteristics of two well-established, though not popularly understood, antenna designs. The first is a cross-spherical cage antenna, which has the overall physical characteristics of an atom. A large, mostly empty sphere with a ribbed rather than solid structure for its outer shell. But this antenna is not dynamic like an atom. An atom's outer radiation shell, or outer electron orbital shell, has a dynamic rather than stationary element, which we call an electron. What we have to consider then is another antenna's characteristics. The far right picture is a large phased array antenna. While most directional antennas have to be physically rotated to alter the direction of the primary propagation beam, a phased array antenna can accomplish the repositioning of its primary propagation beam electronically, without any physical movement at all. It is the combination of the characteristics of these two antennas that is most like the radiation patterns we would expect to see from an atom. When an atom becomes excited above its rest state by shining a light on it or heating it, the energy pressure inside the electron shells increases. We can see the energy being absorbed by simply looking at the energy absorption spectral lines of the atom. If this process continues on long enough, one of two things will happen. As we saw earlier, some frequencies of light waves will simply go around an atom. Some frequencies will be deflected or reflected by the atom, while yet other unique frequencies of light will actually be able to penetrate past the electron shell. Because the electron shell is basically a void, an environment much like a black hole as we discussed earlier, in order for the wave to propagate through it, some energy particles must actually be pushed past the electron into the shell. Energy absorption and emission is a complex process, with many forces converging on the atom and its outer electrons at any one time. As the external pressure of the energy particles begins to build outside the atom, it compresses it slightly. Thus the electrons speed up in their orbit. If light frequency is such that it can penetrate the electron shell and add new energy particles inside the shell will begin to swell under the increased energy pressure. As the shell expands, the electrons will also increase in their speed within their orbits. At some point, if the excitation of the atom continues to increase, the internal pressures will overcome the electron's ability to contain the pressure and a flash emission will occur. If the excitation is reduced and the external pressure is diminished, the atom will begin to shed the excess energy particles, reduce internal pressure, and return to its normal state. In the picture on this slide, we see at the top a cross-section of antenna radiation pattern of a cross-spherical antenna. To the right of it, we see the three-dimensional representation of the radiation pattern, which appears donut-shaped. An atom, acting like a cross-spherical antenna, would also have a donut-shaped radiation pattern. But because the electrons are continually moving around in their shells, they produce the same effect of the switching on and off of elements within a phased array antenna, and this will cause the donut to rotate around the atom. The end result will be a spherical radiation pattern, just as we see the atoms actually look like when viewed through a tunneling electronic microscope. The concept of using atoms to receive and transmit light, just like any other electromagnetic wave, is more than a theoretical novelty. Today, the practical applications of this characteristic of atoms is being put into practice to harness the electrical power of light, and in doing so to help keep our environment clean. Nanantennas are phased array antennas whose elements are virtually on the atomic scale. These devices are highly efficient at receiving electromagnetic radiation in the infrared frequency range and transferring it as electrical power, just as a radio antenna receives radio waves. When used in solar panels, this technology is far superior to traditional photocells, as infrared light is more plentiful than visual light, especially in inclement weather when the sun cannot be seen because of cloud cover. Infrared light from the sun can still reach the solar panel.